In this video, we'll be going over distinct subsequences. So given two strings, s and t, return the number of distinct subsequences of s which equals t. A string subsequence is a new string formed by the original string by deleting some can be none of the characters without disturbing the remaining characters' relative positions. So if we have AC is a subsequence of A, B, C, D, E, because we can delete B and D to create ACE, and AEC is not because we have moved the positions. It's guaranteed that the answer fits in a 32-bit signed integer. So our first example, where I have a rabbit with extra b, and our second t is a rabbit, so we're trying to find the number of occurrences of subsequences of s which equals to t, and as we can see here, there are three possible ways. Let's go over the thought process. We will first implement a recursive approach. We can have two pointers, I and j, which will indicate our current location inside s and t respectively. Then in each of the recursive call, we have two choices. The first choice is skipping the current character inside s, because we are checking for subsequence of s, so we can skip the current character. And then the second choice only happens if the current two characters are at the two indices are the same. If the two characters are the same, we can move both pointers forward. Now we will want to find the total number of subsequences from both choices. Let's go over the pseudocode. So we will implement the recursive approach. And then what parameters do we need? The first one is s, the input string, and we also have t, the input string. And then we have I, the current index inside s, and also j, the current index inside t. And then what's the base case? If j is out of bound, this means we have found all of the characters inside t. This means we have found one possible way to generate t inside s, so we can return 1. Then if I is out of bound, we have failed to find a subsequence, so we can return 0. Then in each of the recursive call, we're going to create a variable subsequence to keep track of the total number of subsequences. So initially 0. And then we'll first recursively find the number of subsequences x if we move I forward, basically skipping the current character inside string s. Then we'll increment subsequences by x. Then if the current two characters at I and j are the same, this means we can check the number of subsequences by moving both pointers forward. So recursively find the number of subsequences y if we move I and j forward. Then we'll increment subsequences by y. Then we can return the number of subsequences. Now let's go over the time and space complexities. For the time complexities of 2 to the n plus n, where mn is the length of the two input strings. This is because in each of the recursive call, we have up to 2 choices and a depth of n plus n. And space complexity also is equal to n plus n. This is because of the recursive call stack memory. Now let's go over the code. So we're going to implement our recursive approach, passing our 2 strings and also our 2 pointers. 2 pointers initially equal to 0. So string s, string t, and also our current index inside s, our current index inside j inside t. Then if j is out of bound, this means we have found all of the characters inside t. This means we have found one possible subsequence, so we can return 1. Then if I is out of bound, that means we have failed to find a subsequence because there are no more characters to find, so we can return 0. Then we'll first find the number of subsequences if we move I forward, basically skipping the current character inside s. +1 and j, and then we'll check if the number of characters, if the two characters at the indices are the same. Then we can check the number of subsequences if we move both of the pointers forward. We're going to increment subsequences by the number of subsequences if we move both pointers forward. Then we're going to return the number of subsequences. Okay, we've got our TLE error. So this solution is not efficient enough due to overlapping recursive calls. We will optimize this solution using the memorization approach. We will be going over the memorization approach in the next video. Let me know if you have any questions in the comment section below.